Web3 is undergoing a transition from digital asset ownership to digital behaviors. The underlying narrative of ownership is being replaced by the necessity of coordination. Within this framework, every operational cycle proves a simple thesis: execution beats narrative. While early decentralized systems often relied on speculative branding, the current phase focuses on autonomous coordination at scale. Blockchains provide the baseline security, trustless accounting, and cryptographic certainty required to support self-operating software layers. This is the machine economy. In this environment, value moves across automated decision flows at API speed. Because these systems eliminate the latency of human-driven platforms, the most vital protocols will operate entirely below the user interface layer, becoming invisible infrastructure for real-world execution. Traditional applications are engineered to capture and monetize human attention. But in financial routing, human attention introduces latency that degrades the efficiency of capital. This contrast defines the architectural shift. On the left, a human-centric workflow creates a series of manual bottlenecks. On the right, a natural language intent is parsed by an LLM and routed to an orchestrator for immediate execution. Every delay between the intent and the final settlement represents economic leakage. To capture value efficiently, these systems replace human trust with verifiable, automated execution. If an enterprise workflow still requires manual coordination to reach a settlement, it functions as a legacy construct. The primary hurdle in building these systems is the memento man problem. Standard large language model APIs are stateless. Between API calls, an agent loses its operational history. It wakes up with immense processing capabilities, but zero situational memory regarding previous actions. The Paperclip AI Orchestrator acts as a stateful coordination layer sitting above these runtimes. It uses a heartbeat check-in system to force the agent to review its persona, goals, and a file-based para-memory system before every execution. This persistent state allows the orchestrator to deploy a network of executable agents. Instead of disconnected chatbots, the system assigns specific roles to a machine workforce. These specialized units manage distinct operational pillars, from continuous smart contract auditing to automated project management and lead generation campaigns. This stateful runtime transforms text predicting algorithms into reliable economic actors. The economic incentive to automate is driven by a stark divergence in costs. This divergence creates the measurability gap, occurring when automating cognitive tasks becomes cheaper than human oversight. Deploying a single agent architecture here compounds errors. If an agent evaluates its own work, failure probability increases every step. A single undiscovered error derails the entire output. To maintain stability, Paperclip introduces independent multi-agent consensus. When an engineer agent writes code, a separate QA agent audits the work at intermediate checkpoints, resetting the error probability. This automated auditing pipeline identifies reentrancy vectors and gas optimization flaws before code reaches the mainnet. By utilizing this check and balance system, autonomous teams can execute complex engineering and administrative processes without requiring continuous human intervention to maintain reliability. Once an intent is validated, it moves into the settlement layer through the Orchestrator X module. Orchestrator X processes the intent into a verifiable execution blueprint. It parses natural language, identifies the optimal path, and subjects the route to a risk engine integrating the Flare time series oracle. This decentralized pricing ensures swaps are protected from flash loan attacks. The finalized blueprint is then executed across the trinity of DLT. This multi-chain posture abstracts the complexity of different networks, using the XRP Ledger for decentralized liquidity, Algorand for mathematical finality, and Hedera for high-throughput consensus audit trails. Routing assets across these high-throughput ledgers ensures that transaction execution speed remains the dominant operational advantage. Multi-chain assets are secured within a cryptographic core known as the vault. It utilizes hardware-level enclave shields and post-quantum cryptographic algorithms to protect autonomous operations from unauthorized key extraction. The system integrates biometric decentralized identifiers, ensuring that human-in-the-loop authorization is cryptographically verified before major state changes are officially committed to the ledger. Human operators also maintain a secure Telegram Oracle relay, which serves as an emergency circuit breaker to halt autonomous operations if necessary. Under this model, autonomous execution handles the coordination of value, while human operators retain sovereign ownership of the keys. To protect the integrity of this infrastructure, the system must prevent Sybil attacks and align the incentives of the operators with the protocol. Access is controlled by a network-independent gating mechanism. The system triggers a cryptographic check to verify the operator's wallet balance. Requiring users to hold 2% of the native DFI token supply transforms the asset into a mandatory credential for accessing autonomous infrastructure. This global framework currently supports over 120,000 active agents, processing billions in transaction volume with absolutely zero human delay. The Internet is evolving from a communication layer into an execution layer designed for outcomes. This transition replaces manual administrative friction with absolute autonomy. The most efficient financial systems of the future will not rely on human coordination, but on executable intelligence layers that run on logic, not labor.